Right. So yesterday we have completed chapter 1 and 2. Today we will start chapter 3. Chapter 3 generally will have two questions. Only two questions in chapter 3. So what chapter 3 talks about? It talks about the when impact test is required. So when impact testing required for your piping material. See, yesterday I told you when the temperature increases, strength will reduce. So how you will compensate that for? You have to reduce the load. That is the stress. Stress is the load by area. You can see appendix A1. For example, A106 grade B up to 100 degree Fahrenheit 20,000. When you have temperature increases, you can say it will go 19,000, 18,000 like that. Stress will reduce it. What is the minimum temperature we can use it? Any pipe. There are two criteria given in the B31.3, again appendix A1. One is based on the curve. So all materials, piping materials are grouped in four curves. Curve A, B, C, D. So curve A is the worst material. Worst material means low toughness material. Curve B better. Curve C still better. Curve D is the best material comparatively. So which of the material will have high toughness? Answer is curve D. It was asked in 1 volt exam. A material belongs to curve D will have better toughness. Toughness means it can withstand in low temperature also. Even minus 50, it will withstand. It will not fail. Okay, there is one word called transition temperature. You know that what is transition temperature? At which temperature material changes to ductile to brittle. So above this temperature, material will be ductile. Brittle materials are not preferred. When you give pressure, they will break. Sudden load. So the transition temperature means at which temperature material property changes from ductile to brittle. That is a transition temperature. So some materials have a fixed temperature. For example, minus 50. It is given in appendix A1. If it is fixed temperature means any thickness of this material you can use up to minus 50 degrees. Some materials are given a curve A, B, C, D. Curve means there is a table given here. So you have to refer based on the thickness, the temperature will change. Actually, that is the exam question. So let us go to the first appendix A1. I will work it. So please go to the page number 170. Please go to the page number 170. Please take page number 170, appendix A1. You can see here A53 grade B. What is the minimum temperature it is given? B. B means this material belongs to curve B. What is A106 grade B given? Again, it is the B. A333 grade 6 given as a minus 50 degree. You can see here the unit, it is a Fahrenheit. So minus 50. So minus 50 means A333 grade 6, any thickness we can use up to minus 50. If it is given curve B means it is depends on the thickness. So you have to refer a table there. You understand this? Yeah. Okay. Now you can see here. Again, you can see some material here. Curve A is there. A, B. So material. So you can see curve D also. Okay. Now let us work with this only these two material. We will take A106 grade B and A333 grade 6. So I will take A106 grade B and A333 grade 6. So both material I need a thickness. Say thickness, I will take a common thickness for 0.75 inch. This is also 0.75 inch. Now, what we are going to find out is called MDMT. What is MDMT? Minimum desired metal temperature. MDMT without impact test. So A106 grade B, it is given as a B. A333 grade C, it is given as a minus 50 degree Fahrenheit. Now, how to find out the B? So please come to this page number from. So please go to the page number 52. 52. You can see, we can see the thickness is given inch as well as mm. Curve A, curve B, curve C, curve D. So what is the temperature? You can see here, minimum temperature without impact testing of carbon steel material. That is the heading of this. So mark it as a open book. So what is our thickness now? 0.75 inch. What is the curve? Curve, see, I just write this. What is the curve we have taken? Curve B. What is the thickness? 0.75. Just to find the temperature from this table. 0.75 curve B. You can see here inches are there.
Minus 9.4.
No, you should not refer there only. This table only. Curve B. See, this is the thickness. It is given here. Curve A, curve B. What is the temperature? 15 degree Fahrenheit. You can see here curve 0.75 inch. Curve B, Fahrenheit 15 degree Fahrenheit. 15 means plus 50. Okay, 15 minus, they already given some minus. So this is the way. So answer is for here plus 15 degree Fahrenheit. Here minus 50 degree Fahrenheit. Sometimes if the exam question they give a stress ratio, there is one thing called a stress ratio. So I will write a stress ratio also. It is optional only, not mandatory. Say both I am giving same stress ratio, say 0.8. Now stress ratio means the temperature can be further reduced. There is another table. You can see, go to the next page, page number 54. Tabular values of reduction in lowest exemption temperature for steel without impact testing. What the stress ratio we have taken? 0.8. 0.8, how much we have to reduce? You see the stress ratio it is given and the temperature in Fahrenheit it is given. 0.8, what is the value? 20 degree Fahrenheit. You can see here, Fahrenheit only you have to take. 0.8, it is coming as a 20 degree. So what I have to do here, plus 15. So again, we have to minus 20 here. So 0.8 minus 20, we have to minus. Here also minus 20. So what will be plus 15 minus 20? Minus 5 degree Fahrenheit. Minus 50 minus 20, minus 70 degree Fahrenheit. This is the way you have to. So minus 20. No, reduction means minus. You can see the table here. Values reduction in lowest temperature. Reduction means always minus only. All values are minus. That's why they didn't give plus or minus. There it is not a reduction. You can see this table, there is no reduction. This is the temperature you have to handle. That's why they are given specifically plus and minus. Reduction means always minus. Okay, again I will repeat. If any material, they will give the material. So you have to refer table A1B and find whether it is a curve or temperature is given. Just refer the table and answer it. If stress ratio is given in the question, then only you have to minus it. Without stress ratio, the answer will be only this one. If the stress ratio not given, answer will be here plus 15 and minus 50 only. If stress ratio given, the answer changes from minus 5 here, minus 70. So please write this, then we will write a question. We will try the question. So copy this one. So I compared when the curve is there, how to interpret it. Without curve also, how to interpret it.
This is MDMT.
It is MDMT without impact. I will write the question. Just you write this, then we will write. Done? Okay. So I will write a question. V381 Y380. V381 Y380. The question is, what is MDMT without impact test for A381 Y35 1-inch thick material with the stress ratio 0.7. Try to answer this question. A381 Y35. It is in the same page only. A381 Y35 is here. Try to answer this question. One-inch thickness with the stress ratio 0.7. The first one, we have to find the curve. What is the curve? Curve A. This metal belongs to curve A. So curve A 1-inch we have to check. So if you take 1-inch, see curve A 1-inch, 1-inch is here. What is the answer here? 68. 1-inch it is 68. So for 1-inch, it is 68 degree Fahrenheit. Now what is the stress ratio I have given? 0.7. Okay, 1-inch 68, correct. So 0.7, what is the answer? 30. So minus 30. So the answer is plus 38 degree Fahrenheit. That is the answer. So if they ask, very rarely this question asked, it is not a regular question. If they ask, this will be the question. What is the MDMT without impact testing? Material they will give, okay, and thickness they will give. Stress ratio is optional. Again, I am repeating. I am giving both question stress ratio. Without stress ratio question asked, then answer will only here. The answer will be only 68 degrees Fahrenheit. Stress ratio given, you have to minus only always. The stress ratio is always a reduction. Any doubts? You understand this? How to find it? It's not a very difficult one actually. Okay, now Next, there are some exceptions. What is meant by exceptions? Generally, this is a rule. See, in any code book, there will be a rule, there will be exception. So always, what is the exception? Even some materials, curve can be changed. Suppose there is given A. Suppose you are doing normalization. Normalizing, what is the purpose? I explained, I told normalizing means to improve the toughness. Then curve can be changed. So where it is given, you can see the notes here. So this is the curve. The curve only we are actually looking as a table. The curve A, B, C, D. Actually, you have to, for example, our material. Now curve A 1 inch, what is the, sorry, curve A 1 inch, what we have got it? 68 degree. From this curve also you can find the answer. See, this is the curve A. Our thickness is 1 inch. If we match 1 inch here, straight away the 1 inch in the curve A, it will come this side, it is Fahrenheit. So 1 inch curve A will match here. It will be 68 degree Fahrenheit. This is 70, it is 68, it will match. Exactly, this line will be, it is very difficult to exactly match. That's why we are using the table, accurate values. Now, these notes are important. It was asked in the last exam. These are the exceptions. For example, note 2. For any carbon steel material may be used a minimum temperature of minus 20 degree Fahrenheit for category D fluid service. Suppose if the exam question is given as a category D, minus 20 we can use it. Even the temperature is not coming minus 20, we can use it minus 20. That is note number 2. Note number 3. X grades of API 5L, ASTM 381 metal may be used according to curve B if normalized or quenched temperature. Generally, they will come. Now we have seen A381, curve A. But if it is heat treated, normalized or quenched tempered, then it can be curve B. Then the following metal may be used to curve D if normalized. A516 grade plate, all grades, 661 all grades, and 671. This note 2, 3 are important. Note 3, 4, because it was asked in the open book last exam. So when the question is asked, just check the notes. For example, A106 grade B. Only category D means we have to refer the note. Then APA 5L, ASTM 381, this material only refer them. Otherwise, no need to refer the note. Okay. Now, this is the one step. I will go back to this original question. So what is the answer? We got it now. 38 degree. What is the meaning of this? If you want, so A381, Y3, Y35, okay. Y35, 1 inch thick, stress ratio 0.7. So answer you got plus 30 degree Fahrenheit. What is the meaning of this? If you want to use equal or greater than 38 degree Fahrenheit, no impact test required. You want to use this material 38 and above, your temperature, operating temperature, no impact test. Suppose if you want to use less than 38 degree Fahrenheit, this is the symbol of less than. Impact test is required. So less than 38 means, suppose if you want to use a 30 degree or 25 degree or 0 degree, you have to do impact test at the particular temperature. Now we will see how to do the impact test and what is the acceptance criteria, how to accept the impact test. Okay. So there are two types of impact tests. We are using the Charpy impact test actually.
The Charpy impact test. The standardized Charpy impact test has been designed to measure the toughness of materials under impact loading at a multi-axial stress state. A pendulum impact testing machine is used to do so. The pendulum of the machine has a heavy weight at the end. This is lifted into the starting position in step 1. Then the tester checks whether the testing machine has been adjusted accurately. In order to do this, he turns the drag indicator downwards and releases the pendulum without a test specimen. The drag indicator stops at position 0. This proves that the pendulum has the correct starting position and that the friction is correctly compensated. The machine is ready for the tests. First test, strain-aged plain carbon steel S235. This is our test specimen. It has been machined to standardized size and shape with a characteristic V-shaped notch. The tester places the specimen on a support in the low standardized size and shape.
So this is the Charpy V-notch impact specimen. So what are the things you should know? What is the size of the specimen? The length is 55 millimeter. That is a standard specimen. Width is 10 millimeter. Thickness also 10 millimeter. Suppose your pipe thickness is less than 10 mm. You cannot make 10 mm specimen. That specimens are called a sub-size specimen. Standard size is 10 by 10 by 55. 55 mm length, 10 mm width, 10 mm thickness. Then what is the depth of this notch? This is called 20% of the width. What is the width here? 10 mm. 20% will be 2 mm notch. Suppose you are making a 8 mm specimen because of the low thickness, then notch should be 20% of the 8 mm. Okay. So you have to keep horizontal and hit from opposite to the notch.
With a characteristic V-shaped notch. The tester places the specimen on a support in the lower part of the machine and adjusts its position with a centering device. Next, he turns the drag indicator downwards again and checks that everything is prepared correctly. Perfect. The test can begin. The pendulum is released, it swings downwards and hits the specimen with its rounded hammer pool. The specimen absorbs part of the pendulum's energy, so the pendulum doesn't reach the full height on the other side. The amount of energy that has been absorbed by the specimen can now be read off the position of the drag indicator. It only amounts to 13 joules in this test.
So it is a joules here, but against joules is a SI unit. We will use here foot pounds. Okay, that much only. In this, others are not important. So what should be the value you should get? So please go to the page number. Right. Minimum record Charpy impact values. Page number 58. You can see there is a table. So carbon steel and low alloy steel, you can see less than, this is the tensile strength of the material. Less than 65 KSI, average 3 specimen, fully deoxide steel, there is a value in foot pounds. Other than fully deoxide, there is a value. Now, exam question itself, they will clearly say it is fully deoxide or not. Okay. So no, don't worry whether it, how I know whether it is a fully deoxide or not. Exam question will be clearly. So we will take it as a other than fully deoxide. So what should be the average for 3 specimen? 10. Minimum for 1 specimen is 7. Now it is 65 KSA and less. From where we will find out the tensile strength? Same page. You can see here our 381 Y35. What is the tensile strength here? 60. Tensile strength we can see from there only. Okay. So let us work in that only. Let us take other than, because I didn't mention any deoxidization. So other than fully deoxide, what should be the average value? 10, minimum 7. Now it is 65 to more than 65 and 75, that should be 1310, and more than 75 up to 95 fully dioxide only we have the impact value. Other than full oxide, there is no impact value. So we have to go for lateral expansion actually. Okay, that is not important for us. So let us work it on this. Of our case, it is 10.7. So first what are the things you should know about the impact test? So which type of impact test we are doing? Charpy impact test. Then we will not test one specimen. We will not test one piece. It is always one set. So one set means equal to 3 specimen. You have to remember, many exams this is asked in the closed book. One set means 3 specimen. Now, which specification we are using for testing? A370 specification. Specification for impact test. So what is the value we got? Average, what is the average value for this one? Because we are talking about this specimen. Average is 10 foot-pounds. Minimum 7. Now, what is mean by average and minimum? When you are testing 3 specimen, you will get 3 values. Average, we have to do it average. Average should be 10. Minimum means single specimen minimum should be 7. But there is a small concession. What is the concession in the set? In any set, one specimen below average. Suppose one is below average. Average, what we record is a 10. The set is acceptable. So one specimen can go below average, it is allowed. Suppose 2 specimen below average, it is not allowed. So 2 specimen below average, not acceptable. And the minimum value, even 1 specimen below minimum. Not acceptable. See, when you take the test, rule is all specimens should have at least 10. But if it is one specimen is 9, others are 12, 13 like that, it is allowed. But 2 specimen less than 10, 9, 8, it is not allowed. Even 1 specimen below 7, it is not allowed. Okay, this interpretation is very, very important. Suppose if it is rejected, then what you have to do? Code allows a retest. We can go for a retest. But when you are going for retest, this 1 specimen below average is, that concession will not be given. So all specimen must be above or equal to average. So for retest, all values should be greater than or equal to average value. Please write this. Please write this. We will work it out. We will do one calculation.
This belongs to MDMT or MDMT?
MDMT already completed. This is impact structure. If you want to use below the temperature, then you have to do impact test. This is how to do impact test and what is accepted. That is 2 parts. First part is when impact test is required. MDMT without impact test. Second part, how to do the impact test. So please write this, then we will complete. The tensile strength. This table is based. That table A1 only you have to take it. Section 9 also the tensile strength, but you can take it from there because curve you are going to refer the anywhere there. So you can table A1, you can refer. Completed? Right. Now attend one question. From your question bank only again. Okay, question number 63. Try this question. They are given deoxidized. Read the question. Try to answer it. No need to write the question. It is your from question bank. Just write the number and answer.
Average value 10 வேணும். அது 95 லீக் என்ன வரும்? ஆவரேஜ் 10. ஜீவன் வந்து 10 இருக்கு. வந்து நீங்க போக மாட்டீங்க. வந்து மினிமம் கீழே போகக்கூடாது, 10 கீழே போகக்கூடாது. கீழே போகக்கூடாது. மினிமம் 10 இருக்கணுங்க. அப்போ ஒவ்வொரு அது வந்து ஓகே ஆச்சா? இது வந்து 13 சரி.
What is answer? C. So A is not okay because one reading is 9.5. B is okay because it is exactly 10 only. So answer is C. B is okay, A is not okay. This is the way you have to answer. So they are given both 65,000. So how to answer is here 65, here 60. So if you go this, you can see 65 and less, both will same. And they given question that is fully, they are deoxidized. So deoxidized, if you take deoxidized, average is 30, minimum is 10. So I told you one value can be less than 13. Here one value can be less than 13, but it cannot be less than 10. So, but it is less than 10, so it is rejected. Here one value is less than 13, but it is not less than 10. So that's why it is accepted. This is the way you have to interpret it. Okay. So please take chapter 3, we will go from starting. That's all actually in the chapter 3. These are the key points we have to cover. So please take page number 48, chapter 3. Materials. Now, as per B31.3, material can be classified into 4 groups. Listed material. Listed means the table A1, it is there. We can use it. Unlisted material. It is not in table or appendix A1, but it is covered in ASME section 2. That also we can use it. Third one is unknown material. Suppose you have a pipe without any details, you should not use it for the pressure class. A pipe without any identification should not be used. Fourth one is called reclaimed material. Reclaimed means you are purchasing a already used pipe. That is reclaimed. It is allowed by the code, provided it is properly identified, completely clean. Okay, you can see here listed, unlisted. Highlight this unknown material. This is important. Material of unknown specification shall not be used for pressure containing piping components. Reclaimed, we can use it. Then temperature limitations. Highlight the 323.2.1. Wherever I have underlined, highlight it. A listed metal may be used at temperature above the maximum for which a stress value or rating is shown only if there is no prohibition in the appendix A. So we have to, what is the maximum temperature we can use? The stress limit. If there is dash, then you should not use it. So this is the minimum temperature, lower temperature limits. I highlight the B1. The stress ratio is used in figure 322 point to determine the allowable reduction in the impact test assumption temperature. If stress ratio is given, it can further reduce. Please remember, stress ratio values are always minus. We have to reduce it. Then please go to the, these are not important.
Apart from this highlighted one,
No need to read, no need to read.
highlighted some.
Which one?
Officials highlighted some.
Yeah, that is generally you have to read it. But the exam point of view, whatever I am telling, highlight it, read that only. That one only.
We don't have that much time, so we can avoid that.
Yeah, you can avoid that one. Only whatever I am telling here, underline in my book, and I am telling, asking you to highlight it. Just read that much. So this is important. I already told. There are some exceptions. So curve can be changed. See, again I will repeat. Any carbon steel material, if it is given in category D in the question, straight away up to -20 we can use it. That is the note number 2. Any carbon may be used a minimum -20 °F for category blue. The next note, AP5L X 6550 or ASTM 381 materials may be used curve B. Generally, there will be curve A in the table. If the question it is mentioned normalized, then it will become curve B. Okay. There is a question bank. In our question bank, this type of question we have covered. And the following material may be used to curve D. So generally, this material belongs to curve B or C. But if you are doing normalized, then it becomes a curve D. See, when you are doing heat treatment, the toughness will be improved. So it will change the curve. Then this table, you know how to use it. I already explained you. Mark it open book. The next one, page number 54. This table, you know how to use it. Mark it as a open book. That is stress ratio. Then please go to the page number 55. Impact testing methods and acceptance criteria. Page number 55. Highlight this one. This is important. 323.3. Impact testing of each product form of material for any specification shall be done using the procedures and apparatus ASTM A370. That is closed book question. Page number 55. 323.3.2. Now, recently there is another. For material forms that are represented by the ASTM specification listed below, impact test shall be conducted in conformance with those requirements as well as when the conflict exists between the specific requirements of this code and the requirements of the specification, the requirements of this shall take precedence. What is meaning of this? Suppose you have a A333 grade 6 probe. We have to do impact test as per 370 or as per A333 also you have to follow. But both are same values, no problem. But there is a conflict means we have to follow 370 only, not A333 grades. You can see here, for material forms that are represented by ASTM specification listed below, impact test shall be conducted if conformance with those specification as well as we have to do that requirement also we have to meet it. But there is a conflict means ASTM 370 different requirements, 333 we have to follow 370. This was asked in the one of the open book exam last exam. For A333, which of the following specification we have to use it? A370 and A333. Both the specification we have to use. Then test specimen, close book question. Each set of impact specimen shall consist of 3 specimens. Very simple, and many exam this question asked. Impact test how many specimen? 3 specimens. Then lateral expansion. See, generally up to 95 only we have above that lateral expansion. Just to highlight it, this is not important. Other carbon steel, lower lash steel having specified minimum strength equal or greater than 95 KSA and all bolting materials shall have lateral expansion opposite the notch, not less than 0.38 mm. then these are not
So
important.
in that case, we don't want to refer that.
No, only expansion, how much it is expanded. Next page, this is the absorbed energy criteria. This is what I explained. This is closed book question, mark it. When the average value of 3 specimen equal or exceed the minimum value permitted for a single, and the value for more than one specimen is below the average value. So one specimen below average accepted. More than one below average not accepted. Or when the value of one specimen is below the minimum value, a retest of 3 specimens shall be made. Last line is important. The value of each of these retestments shall equal or exceed the record average. When you are going for retest, all specimens must be equal or exceed the average. No concession allowed. Okay. Then highlight the 3 erratic results. Suppose when you do the impact test, you know the specimen preparation, there is mistake, you can retest it. When an erratic result is caused by defective specimen or there is uncertainty in the test procedure, a retest will be allowed. Under this table, we know already that one, 58, page number 58, mark it as a open book. That's all. Chapter 4. Now we will go to the chapter 5. Chapter 5 will have 4 questions, 3 to 4 questions. Chapter 5 will have 3-4 questions. Chapter 4 not there. Chapter 4 not there because it is only list of specification, only specification numbers only, 3 pages. So that's why we removed it. That's not a question. Chapter 5, fabrication, assembly, and erection. This chapter will have around 4 questions, 3 to 4 questions. Now, you remember pipe can be manufactured in 3 ways. I told you. What are the 3 ways you can manufacture? Seamless pipe, welded pipe, cast pipe. Okay. So casting, where you find the efficiency, EC A1A, appendix A1A. Joint efficiency, appendix A1B, EJ. Seamless, there is this efficiency always 1. So no need to search. It is given in EJ, that there only it is given 5. Okay. Now, that weld is called as a longitudinal weld. That weld is called efficiency. What you are taking this efficiency is called as a longitudinal weld. But in fabrication, when you receive the pipe with the fittings, we are making a weld, piping spools, fabrication or erection. We are not making a longitudinal weld. What welding we are making actually? Circumferential. There is a one more technical name for that weld is called girth weld. What you are making at the site is called as a girth weld or circumferential weld. It is a circumferential weld, pipe to pipe weld, circumferential or girth weld. Now, before starting any welding, the first thing is you have to qualify the procedure. Second thing is you have to qualify the welder. Then only you can start fabrication. So before starting fabrication, a welding procedure should be qualified. That is PQR. Then you have to write the WPS, welding procedure specification. From that only you have to qualify the welder. So which code we will follow for the welder procedure qualification and WPS or welder qualification? Section 9. But there are some changes here. They modified some of the section 9 requirements. For example, let us first come to the PQR. As per section 9, backing strip, I told you what is backing strip. Retainers, consumable insert, these are considered as a non-essential variable. Non-essential means even if you use it without, also we can write a WPS. Even if you don't use it during PQR, we can write WPS with, you can add or delete. That is the meaning, non-essential. But as per B31.3, if you want to make a procedure with the consumable insert or backing strip, we have to use it in the PQR, like essential variable. We have to strictly follow. That is one. Second one is, as per section 9, you cannot use other companies' procedures. Procedure should be qualified by the organization itself. You cannot borrow the procedure. You cannot say, I don't have the procedure, okay, I will use that company. No, you cannot use it. Unless both companies are managed by the same management. If they are same management, we can use it. Otherwise, if it is a different management, you cannot use it as per section 9. but B31.3 allows that one. B31.3 what it says, if owner accept that, you can use other company's procedure. Provided you should not change any of the procedure required. You just same procedure, you will copy it in your letterhead or your prepared. You have to sign it, you have to take responsibility, you can use it, provided it should be accepted by the owner. Same way, in section 9, you cannot use other company welder also. But B31.3 allows that one. You can use other company's welder, provided accepted by the owner. No need to again qualify the welder. If it's already qualified by some other company, you can use that. Okay. So these things you should know about the first before starting. Then welding requirements we have, preheating requirements we have, PWC requirements we have. Generally preheating they are not asking in the exam. Regularly PWC requirements they are asking in the exam. So let us start.
So which do you want to follow?
Which one?
B31.3 or section 9?
Always B31.3. See, B31.3 is the reference code for piping construction. When you are doing a piping construction, you have to follow B31.3 requirements only. It will supersede section 9 requirements. Okay, any reference code for that case.
So it is for only construction.
It is construction.
In service, you have to follow.
In service, it is given B31.3. So in service also we can supersede. If you go 570, welder should be qualified according to section 9 only they are given. You have to follow only section 9. Suppose there is a mention in B31.3, then we can take the consideration. But see, this all codes. There is one more thing called owner specification. Owner specification have more value than the codes. It will be more stringent than the codes. So we have to follow owner specification. Suppose owner specification says you cannot use other companies' welder, you cannot use it. Even the code allows that. That's why they everywhere provided acceptable by owner. There is a condition. Even a common thing. I worked in piping more than 10 years, almost 10 years. As per B31.3, lack of fission, lack of penetration is allowed. But owner specification will clearly write lack of penetration, lack of fission is not allowed in this project. They will not accept in the radial brush.
But from there, they will
Yeah, see, they have the engineering department. So they will say, code, this is the code requirements, we should not accept that one. We have to go more stringent. That's why when you are interpreting or doing any visual inspection or any inspection interpretation, you should have the reference code like B31.3 acceptance criteria as well as the owner specification. Because if you see here, acceptance criteria, we will always use a normal fluid service for radiograph interpretation. Normal fluid service, lack of fusion, lack of penetration allowed by the B31. Practically, it is nowhere allowed in the process pipe. Because owner specification says like this. Okay. So take it responsibility, highlight this one. The employer is responsible for welding and bracing performance by personnel of its organization. See, just 2-3 things, keep it in your mind. Whether it is a welder, whether it is a NDT technician, whether it is a welder or NDT technician, if the exam question is asked, who is responsible for his qualification and certification, answer is employer. His employer only responsible for his certification. He has to maintain a record of his certification. But the next question, who will decide the training requirements? How many hours? It will be decided by always owner. Owner will decide what type of training required. So owner should say whether I need a ASNT level 2 technician or I need a PCN technician or ISO 97. So the training requirements will be decided always by the owner. But who will maintain the records? It will be the employer of the particular person. So who is the employer of the welder? In construction, it is a contractor, manufacturer or contractor. If you go in service, it is called a repair organization. They will have the responsibility. NDT technician, always the NDT organization will have the responsibility. Okay. Any welding bracing performed by personnel in the organization conducting the qualification test required by qualify the welding or pressing procedure, conducting the record to the qualified welder, bracer or operators. Now, you can see here, welding and procedure specification to be followed in production welding shall be prepared and qualified, and welders, bracer, and operators shall be qualified as required by ASME section 9, except as modified in para 333. So there are some modifications are there. Now this is important. 328.2.2 procedure qualification by others. In order to avoid duplication of effort and subject to the approval of the owner, WPS, BPS means the bracing procedure specification, qualified by a technically competent group agency may be used provided the following are met. That is open the question. You can use other companies' procedures subject to owner, but there are certain conditions. What are the conditions you can see here? The procedure meet the requirements of section 9 and any additional qualification requirements of this code. The employer has qualified at least one welder using the operator following WPS or BPS. Employer business name shall be shown on the each WPS and BPS. The next one, performance qualification. Performance means welder qualification by others. Again, it is acceptable by the code. Highlight this also. In order to avoid duplication of effort and subject to the approval of the owner, an employer may accept the performance qualification of a welder, bracer by a previous employer. So we can accept that one. This acceptance is limited to performance qualification made on pipe or tube. The new employer shall have the WPS or BPS that has followed during the qualification or equivalent WPS. So highlight this lines. Then qualification record. This is closed book question. The employer shall maintain copies of the procedure and the performance qualification records specified by ASME section 9 that shall be available to the inspector at the location where the welding is being done. So WPS and the welder qualification should be available at the site. That is closed book question. Then next page.
This whether we record that party.
There is no third party anywhere in any code. It is not mentioned. It is a self certification only. Okay. Next page. Page number 64. You can see that non-metals or non-metallic backing rings. Backing rings of the non-ferrous non-metallic may be used provided the designer approve their use and the welding procedure using them is qualified. Required by. So as per section 9, it is not a requirement. It is a non-essential variable. But here it is a mandatory. Consumable insert, again it is a open book question. Consumable insert may be used provided they are the same nominal composition, will not cause detrimental, and the welding procedure using them is qualified. So again, consumable, I will show you the video maybe during the break. These are not important. Then please go to the page number 66. Now, every welder, each and every welder should have a number, welder identification number, or letter or symbol. That number should be stamped near the weld. Preferably hot stamping, punching. If it is not allowed, you can write. That also not allowed means you can maintain a record on the drawings. Okay. So highlight this one. Each qualified welder or welding operator shall be assigned an identification symbol unless otherwise specified in the engineering design. Each pressure containing weld or adjacent area shall be marked with the identification symbol of the welder or welding operator. In lieu of the marking, appropriate record shall be filed. So you can fill the records. Then when you are making tack weld, so how they are making the pipe joint, they will make a clamp, make a tack weld. Directly you are making GTAW for tack weld. You can fuse it and weld it. Any crack we will remove. Sometimes you can see there is a making a small bridge pieces that you have to remove it. Tack welds at the root of the joint shall be made with a filler metal equivalent to that used in the root pass. Tack weld shall be made by a qualified welder or welding operators. Only qualified welder to make tack. There is no separate qualification for tack welder. Only qualified welder should make. Tack weld shall be fused with the root pass, except those have cracked shall be removed. Bridge tacks shall be removed. Then highlight the D. Peening is prohibited on the root pass and the final pass of the weld. Peening means using a ball peen hammer vibration. Okay. Again, so So this is actually feeding. You can see a ball peen hammer. Actually, it is one of the stress relief. This one. It is continuously vibrating. It is one form of stress relief, but it is not allowed in the code books. If you are going to do PWC, you can do peening, but the peening itself is not considered as a replacement for PWC. There's another one, consumable insert. I will show you because I'm repeatedly selling consumable insert. So this is the consumable insert used in the GTAW. I will play only
Walmart School of Welding Technology. Rust contamination.
Yes, from here.
In addition, clean white gloves are recommended to handle the grease. Place the insert at the end of
This is
one
a
of the
free
prepared
place
joints.
refiller wire, consumable insert.
Note that the insert is slightly larger than the pipe, which will produce some overlap. Fit up should be as accurate as possible. Small tack weld within 2 inches of the ends of the insert. This tack weld is made without filler metal and joins the insert to the joint bevel. Start the arc on the bevel and melt a small portion of the bevel into the insert. Deposit tack welds every 1.5 to 2 inches until the overlapped portion of the insert prevents good fit up. A hacksaw or hand shears are used to cut the overlapped portion of the insert. Care must be taken to fit the insert accurately against the joint edge to prevent cutting off too much of the insert. After cutting, the gap between the 2 ends of the insert should not exceed 1/32 inch. Now finish tack welding the remainder of the insert using the same procedure. Place the last tack weld in the gap between the ends of the insert. Now, place the second pipe nipple against the insert to form the complete joint. The boot face should fit tight against the insert. Deposit small tack welds to join the insert to the second pipe. These welds should be located halfway between the existing tack welds. Start the arc on the first pipe bevel and form a puddle. Carry the puddle across the insert and onto the second pipe bevel. These tack welds should fuse the consumable insert into both of the bevel edges. Use filler metal to join the 2 ends of the insert together. Filler metal should be added until the hole is completely filled, flush with the insert. Now, reinforce the tack welds at the 3, 6, 9, and 12 o'clock positions, the size of 1/4 to 1/2 inch. The repaired joints must be as consistent as possible. High quality weld.
So this is the consumable insert. They will just use a tick touch, then fuse it, so that you can get a uniform route.
Since the welder does not have to manipulate a filler metal rod. Regardless of the type of insert, the procedure for assembling the pipe joint is the same. Inspect the assembled workpiece and then check with your instructor.
There is one more thing. What is meant by retainer? Retainer is a ceramic material. So you can see the fit up, they were using the ceramic to backing instead of metallic ring. That is a retainer. So you can see here. So this is the ceramic insert. Okay, so get the uniform. See, the purpose of all this thing is to get the root penetration uniform. Which process they used for this welding? Which process? You watch this video. No, it is not a TIG. It is FCAW. Flux code arc welding. You can see flux there. This is similar to GMAW. Only thing is there is a flux there. Hello? Ama. வெயிட் பண்ணு அந்த கால் பண்றேன் உங்களுக்கு நான் கால் பண்ணேன் நீங்க தெரிஞ்சு So this is the consumable insert. They use the FCAW process. Okay, we'll go back to the code book. Now, peening. So we started, I explained peening. Peening is using a ball peen hammer. Purpose is to control distortion and relieve residual stress. But the peening is prohibited on the root pass and the final pass. Okay, that highlight this one. Then highlight the E. No welding shall be done if there is impingement on the weld area, rains. No. So when there is a rain, you should not weld it. Then welding end wall. The welding sequence is a procedure of any heat event for welding end wall shall be such to preserve the seat tightness. Then seal weld. So I told you seal weld means threaded connections. What you are welding is seal weld. Seal welding shall be done by a qualified welder. Seal weld to cover all exposed threads. Highlight that also. So you will cover when seal welding any exposed thread we have to cover. Then please go to the page number 68. So this is the socket weld gap. This is important. Approximately 1.5 mm gap before welding. When you are making a socket weld, you have to insert the pipe and maintain a gap of at least 1.5 mm approximately before welding. Then these are not important. Then weld repair. Page number 69. Now, so how we will weld repair? It is covered in actually 577 also. See, if you take radiography and there is a defect, so who will mark the area for repairs? Inspector. It is the inspector responsibility to mark the area for repair. Who will do the repair? It is actually welder should do the repair. So he has to remove the weld to the sound metal. Sound metal means defect free. Sometimes crack type defects we can confirm it by using MT or PT also, whether it is gone off. Then we have to make a welding using the procedure. Generally, it will be a original procedure, but it is not always possible to use a original procedure because suppose you are making a submerged arc welding. Repair by submerged arc welding is not possible. So they will go for a SMAW. But important thing is preheating PWC requirements, you have to follow the original procedure. Originally, there was a preheating, you have to do preheat. For repair, PWC also you have to follow. So highlight this one. A weld defect to be repaired shall be removed to a sound metal. That is closed book question. Sound metal means a defect free. We have to remove it. Repair weld shall be made using a welding procedure qualified in account 328. Recognizing that the cavity to be repaired may differ in contour and dimension. Repair weld shall be made by welders or welding operators qualified according to para. Preheating and heat treatment shall be as required by the original welding. Then these are not important. Then please go to the page number preheating 71. So what is the purpose of preheating? To avoid hydrogen cracking. Before starting we will weld, preheat is required for tack weld, even any seal weld we are doing, or butt weld, all preheating do. So how much distance we have to preheat it? Generally, where you are going to start welding, at least 3 inches away, only we will mention the preheat. So highlight this one. The preheat requirements herein apply to all types of welding, including tack welds, repair welds, and seal welds. That is closed book question. Then unlisted material 331. Preheat requirements for unlisted material shall be specified in the WQS. So we have to specify the WQS and follow. Then preheat temperature verification. How to verify the preheat temperature? By using a thermal indicating crayons or pyrometers. Highlight this one. Preheat temperature shall be checked use of temperature crayons, thermocouple pyrometers, or other suitable means to ensure the temperature specified is obtained prior to and maintained during. Then how much area preheat you have to do? That is again closed book question. The preheat zone shall be at or above the specified minimum temperature in all directions from the point of welding for a distance of larger of 3 inches or 1.5 times greater nominal thickness. Tack weld it is only 1 inch. Next paragraph. The base welded temperature for tack weld shall be at or above the minimum temperature at least 1 inch in all directions. Now, suppose you have different P number materials. Now understand this is the basic in all courses. There is one thing called transition joint. What is meant by transition joint? When you are making two different thickness or two different materials. Suppose when you are making two different materials, for example, carbon steel with low alloy steel. Carbon steel 200 degrees centigrade preheat, low alloy steel 300 degrees centigrade. Which one you have to follow? Higher one. Preheat, PWST, we have to always follow the higher temperature. Okay. Radiography, material doesn't matter. Then coming to the thickness. If you have different thickness, same material, carbon steel, one side 10 mm, one side 15 mm, you are fine. Preheat, PWST, higher thickness only we have to take for calculation purpose. Radiography, always thinner one. Acceptance criteria based on the thinner one. So when you are using different thickness, only radiography thinner, preheating PWC thicker. Different materials, preheat PWC, always the high temperature you have to follow. Okay. So highlight this one. When welding two different P number materials, the preheat temperature shall be the higher temperature for the material being welded. So higher temperature only we have to take. Now the next page, preheat temperature. This is not very important, but you should know that how to preheat temperature, we have to find it. Table 330.1.1. So it is based on the P number. Now, minimum preheat temperature is 50 degrees Fahrenheit. First, we will start with the carbon steel, P number 1. This is the base metal P number. That's why I told you that you should know P number. P number 1, there are two conditions. Please understand this, even though generally they are not asked. One is the thickness, second one is the carbon percentage. If the thickness also more than 1 inch, carbon percentage also more than 0.3, then you have to preheat 200 degrees Fahrenheit. If both conditions are met, 200. If only one condition is met, 51. Even no condition is met, 51. You can see here, thickness also less than 1 inch. There is no addition limit, 50. Thickness is greater than 1 inch, but carbon percentage is less than or equal to 0.3, 50 only. When the both conditions are met, thickness also greater than 1 inch, carbon percentage is also greater than 0.3, then it will be 200 degrees Fahrenheit. Now coming to the P3, again we have two conditions, but here even one condition is met, we have to do 200 degrees Fahrenheit. Here what are the conditions? Tensile strength 65, thickness half an inch. You can see here, thickness less than or equal to half an inch, tensile strength also less than or equal to 65, 50. Second, when the thickness is more than half an inch, even tensile strength is less than 65, 200. When the tensile strength is more than 65, any thickness we have to do 200. Now, P number 4, any metal we have to get 250. There is no condition. P number 5, a tensile strength less than or equal to 60, 300. Greater than 600, 400, 60, 400. So only this we have to know. Right? So if you understand this, no need, this is not important actually, we will skip it otherwise. Now we will go to the PWST. Okay. So how we are doing the PWST? There are two types of PWST. One is called furnace PWST. That's why I'm looking for the picture. There is a picture. 1 minute. What is the question? So this is called a furnace. A furnace, inside you can fabricate the spools, keep the pipe inside, many pipes inside, and close the furnace, and you can do the PWST. PWST, what you are doing, we are slowly heating, holding, cooling. That is the PWST. Then suppose a pipe is lengthy pipe, it is not completely going inside a furnace. For example, the pipe is very lengthy pipe. So for example, this cap is outside. You can cover with insulation, do the PWST here, then take the pipe and return it like this. But there should be at least 1 feet overlap. The previously which is inside furnace, again go to the furnace. Then another type of PWST is called local PWST. So this is the local PWST. You can click heater and you can do the PWST. So how the PWST graph, this is the furnace vessel actually, vessel PWST. So graph will be look like this. This depends on which axis you are having. Now, if we take the PWST graph, so this is if you take time here in y-axis and the temperature in x-axis, the graph will be like this. This is the shape of the graph. And this area is called as a heating. This is called as a holding or soaking. It is called as a cooling. Now, what is the rules in this? 600 degree Fahrenheit above only we need a controlled heat. Below 600 we can heat it fast. And this temperature is called as a holding temperature. It is for carbon steel, it is 1100 degree Fahrenheit. So from 600 to 1100, what is your heating rate? The rules is heating rate, heating and cooling rate. Both are same only. Cooling rate 600 degree Fahrenheit per hour divided by half of the thickness. Always in inches. For example, your thickness is 1 inch. 600 divided by half of the 1 inch is 0.5, but it will go 1200. That is not allowed. There is another rule, maximum 600 degree Fahrenheit per hour. Suppose your thickness is 4 inch. What is half of the 4 inch is 2 inch. 600 divided by 2 inch will be 300. So for example, for 1 inch thickness, if you apply the rule 600 degree Fahrenheit divided by half of this 0.5, it will come 1200, which is not allowed because maximum allowed is 600 degree Fahrenheit per hour. Suppose your thickness is 4 inch, then it will be 600, half of this is 2 inch, then you have to heat it 300 degree Fahrenheit per hour. This understanding is important. Now, exam point of view, they will ask what should be the holding time. So 1 inch per hour is a rule, minimum 15 minutes. But when the thickness is more than 2 inch, we will add only 15 minutes. The table is actually very important for exam. Just write this, then we'll.
அது வந்து என்ன இப்போ MDMT-னா இன்னைக்கு MDMT என்ன ஸ்டேபிள்
பிளாஞ்சு தான் 2% இருக்கும். பிளாஞ்சு தான் எல்லாமே பிளாஞ்சு தான். பிளாஞ்சை பத்தி தான்.
ஒன்னு போட்டுட்டு இன்னொன்று
இல்ல கால்குலேஷன் திருப்பி ஒரு தடவை பார்ப்போம். பாருங்க 2 செகண்ட் டைம். சரி
பார்க்கும்போது இதுவா
இல்ல கிடையாது. MDMT அதுல என்டையர்லி டிஃபரன்ஸ். பிளாஞ்சுன்னு வந்தாவே 16 பாயிண்ட். இங்க பிளாஞ்சை பத்தி எதுவுமே இல்லை. ஆமா அந்த சம்மரி ஷீட் அந்த இண்டெக்ஸ் தான் சம்மரி ஷீட். அந்த மாதிரி சம்மரி ஷீட்லாம் எக்ஸாம்ல உங்களுக்கு ஈஸியா இருக்கும். ஓகே, so we'll take PWST. Okay, so now why we are doing PWST? First, what is the purpose of doing PWST? To stress relief. Generally, PWST based on two things. One is based on the P number and the thickness. A carbon shell above particular thickness, you have to do it. Carbon shell, now the thickness based PWST is removed. No need for carbon shell. So for piping carbon shell, any thickness, PWST is not. But there is one more thing is that base to avoid stress corrosion cracking. That is called environmental cracking. Service, based on the service we do this. We call it as a NACE service or source service. We have to do PWC. That requirement is still there. That PWC we have to do this. So that PWC not depends on the thickness. All thickness we have to do. For example, yeah, piping is in caustic service. So avoid stress corrosion cracking, we have to go for 100% PWC. Amine service, we have to go for 100% PWC. That PWC is still there, but for carbon shell, based on the thickness, PWC is removed. Okay, that exemption, there is an exemption table is there, but they never asked in the exam. Now, PWC, what is meant by thickness? Butt joint, we have to take the base metal thickness. We never consider the reinforcement. Fillet weld for PWC thickness, we will take a throat thickness. I explained already what is throat, what is like throat thickness. And reinforcing pad, there is a calculation is there that never asked in the exam. So you can see here, the thickness in the pressure of the weld, which is factor to determine the control thickness, is defined as follows. Groove welds, girth and longitudinal, the thicker of the two operating. So whichever is higher thickness, we have to take. Fillet weld, we have to take the throat thickness. Partial penetration, depth of the weld groove. Repair weld, depth of the repair only. So because based on the thickness only, how much time we have to give, holding time. So thickness is the butt weld, this is the pipe thickness, we will see. Now, this is open book question, what I told you before the break. Above 600 degree Fahrenheit, the rate of heating and cooling shall not exceed 600 degree Fahrenheit per hour divided by one half of the maximum material thickness, but in no case shall the rate exceed 600 degree Fahrenheit per hour. That is important open book question. 331.1.4. Now we will go to the next table. This table is very, very important. This is the regularly asked exam question table. PWST, how to calculate the holding time. Okay. See, for example, P number 1, if we have P number, group number 1100 to 1200, that is a holding temperature. Holding time, just to understand this one. This is the one exam they are testing actually. 1 hour per inch, condition number 1. Second condition is 15 minutes minimum. What is the meaning of this? Up to 2 inch. Suppose your thickness is 2 inch. We have to give 2 hours. 1.5 inch, 1.5 hours. 1 inch, 1 hour. Half an inch, half an hour. 0.25 inch, quarter hour. Quarter hour means 15 minutes. Less than 0.25 inch also, we have to give minimum 15 minutes. So minimum cannot be less than 15 minutes. Call inch is common narrow. After that, it will be continuously increased up to 2 inch. But 3 inch, it is not 3 hours. So you can see next condition, over 2 inch, the condition will change. 2 hours for 2 inch plus 15 minutes for each additional inch over 2 inch. So 3 hours, only 15 minutes you have to add. 2 hours, 15 minutes. Thickness 4 inch, 2 hours, 30 minutes. Every additional inch over 2 inch, we have to add 15 minutes only. Okay. So again, I will repeat, 2 inch, 2 hours, 1 inch, 1 hour, half an inch, half an hour. But below quarter inch, quarter means 0.25 inch, 15 minutes is the minimum. It cannot be less than 15. But more than 2 inch, it is not the straightforward. Every additional inch, we have to add 15. Suppose 2.5 inch, you can round it 3 inch. Upper side, you can round. Now, this one last exam they asked, what is the holding temperature he has given? P8. PWC is not required unless required by the WPS. It was asked in the open book last exam. P8 generally PWC is not required. Stainless steel we are doing. So this is the answer. Mark it as a open book. It is asked in the last exam. Now, let us see the carbon shell. What is the carbon shell holding temperature? Minimum 1100. P3 also 1100. This P1 and P3, even the temperature you can reduce it and do PWST. There is a next page, there is a table. You can see here alternate post-wall heat treatment for carbon and low last steel P number 1 and 3. This table also important. Now try to understand this table because this table also regularly they are asking questions. For example, if you reduce 50 degree Fahrenheit, so what is the temperature, minimum temperature holding? 1100. If you reduce 50 degree, minimum we have to give 2 hours. Reduce 100, minimum we have to give 4 hours. 150 minimum 10 hours. 200 minimum 20 hours. Now, for what thickness this duration? 2, 4, 10. You can see the note 1. Time shown applied to thickness less than or equal to 1 inch. Even half an inch, you have to give 2, 4, 10. We will not cut half of this. And if it is more than 1 inch, add 15 minutes per inch. See, the previous table, more than 2 inch, we will add 15 minutes per inch. But if it is half an inch, we will reduce it. But if here, 1 inch or less, this we have to follow. More than 1 inch, we have to add 15 minutes. Second one, note 2, you can see 150, 200 is allowed only for P number 1. A decrease greater than 100 degree, note 2, below the minimum specified temperature is allowed only for P number 1, group 1, 2 materials. So P1, group 3 also not allowed, P3 also not allowed. Okay. So these two tables, regularly they are asking exam question. Let us check how much you understand these two tables. So I will write the P number, temperature and the thickness, you have to write the holding time. So P number, thickness, holding temperature, holding time. 1, 5 inch, okay. Answer this two, this 4. So you have to write the holding time. I write the P number 1 and 3 only I write. See how to answer is you have to see the holding temperature. If it is 1100, you have to refer this table, original table. Reduction means you have to refer this table. That's all. Try to interpret. Reduction means second table. Original temperature we are using means original table you have to. They are separate tables. Don't mix up two. Write this, then we will pass. Write in your notebook. Then I will let everybody complete. Then we will. This is the way you have to answer. Okay, how to answer it, I will explain. So first one, 1100 degree Fahrenheit, P number 1. So we have to refer this table. Okay, this table. So 1100, what is the thickness? 5 inch. What is the rule over 2 inch? 2 hours for 2 inch plus 15 minutes for each additional inch over 2 inch. So extra we have 3 inch, total 5 inch. So 3 inch 15 minutes means 45 minutes. 2 hours plus 45, 2 hours 45 minutes. Then how to answer the second question? Second one. See, what is the second one? We can 900. So second table we have to follow half an inch. So how much reduction? 900 means 200 reduction. So if you can see here, for 200 reduction, we have to give 20 hours. You can see the note. Time shown applied to thickness less than or equal to 1 inch. If the thickness is 1 inch or less, we have to give 20 hours. So our thickness is half an inch, 20 hours. Third, what is the third one? P number 3, what is the temperature? 1000 degree Fahrenheit. 1000, what is the thickness? 1100, 1.5 inch. So 1.5 inch, again we have to go to the original table. Original table, you can see 1.5 inch will come under this one after 2 inch, 1 hour per inch. So 1.5 inch, 1.5 hour. Fourth one is 1000 degree. So we have reduced 100 and 3 inch. So you can see here this table, next table. So when you reduce 100, it is 4 hours for 1 inch thickness. You can see the nose. Time shown apply 1 inch. Add 15 minutes of thickness over 1 inch, greater than 1 inch. So 3 inch means 4 hours, 30 minutes. Extra we have to add 15 minutes. 4 hours, 30 minutes. This is the way you have to answer.
4 hours or 1 inch?
1 inch. 1 inch or less. You can see the note 1. Read the note 1. எவ்வளவுங்க டெம்பரேச்சர் பண்ணிருக்காங்க 900. 900 how much reduction? 1100 minus 900, what is that? 200. 200 reduction, this table how much it is? 20 hours. You can see 200 reduction, not 20 hours. This is the reduction in Fahrenheit. 20 hours we have to give. If the thickness is 1 inch or less, we have to give 20 hours. More than 1 inch, we have to add 15 minutes for every inch. Okay, these two tables are important for exam. Regularly, there will be one question at least from any of this table. This table, again, I am repeating because you have a very short period for your exam. Whatever I say important, just to go through it. Okay. Okay, we'll continue this. We have a lot of question in your question bank. Now, alternative heat treatment. Suppose you are going to do normalizing. You remember yesterday I told normal upper critical temperature, you are going to do some heat treatment. It is allowed. Okay. Normalizing and tempering or annealing may be applied in lieu of the required heat treatment after the welding, bending, forming, provided the mechanical properties of and base metal meet the specification requirements. That is a closed book question. Then partial heat treatment. That also I told you. Suppose furnace, when you are doing complete piping is not going inside, so there should be a 1 feet overlap. So highlight this one. When an entire piping assembly to be heat treated cannot be fitted into the furnace, it is permissible to heat treat the more than 1 heat, provided there is at least 1 foot overlap between the successive. That is a closed book question. Then local treatment. Suppose you are using the heater coil, what should be the width of the heater? Generally, it is a 3 times thickness. You can highlight this one. Wells may be locally forceful heat treated by heating a circumferential band around the entire component. The width of the band heated to the specific temperature shall be at least 3 times the wall thickness of the weld at the thickest part. 3 times the wall thickness. Now we will go to the bending and forming. This is the next page, exemption. This is not important. I told you, see, P number 1, all group number, all, there is no PWC record. It is exempted. Only we have to do preheat. P3 also, less than 16 mm not required. This table is not important for exam. So please go to the page number 78. Now, what is meant by bend flattening? When you make the bend like this, this area, bending means you are keeping the pipe. Hot bending means heating the bending above the transformation range. Transformation means above 700. Cold bending is below or room temperature. Suppose there is pipe is ovality. Ovality means it is not circular. Pipe become like this. How much ovality is allowed? Okay. So how to measure the ovality first? We have to measure the what is the maximum OD. So this is the maximum outer diameter, and this is the minimum outer diameter. So the maximum OD minus the minimum OD should be less than or equal to 3% of the OD. Actual OD. For example, OD is say 100 mm. Maximum say 103 mm. Minimum say 98 mm. What is the difference here? 5 mm. It is not allowed. 3% means 3 mm only allowed. This is not important for exam. Just you should know this requirement. So highlight this one. Flattening of the bend. Sorry, it is not 3 mm, 8%. External pressure only, it is 8% for internal pressure. So 5 mm is allowed. Okay. Highlight this one. Flattening of the bend, difference between the maximum and the minimum diameter at any pressure section shall not exceed 8% of the nominal outside diameter for internal pressure and 3% for the external pressure. Removal of metal shall not be used to achieve the requirements. Just to mark it close book, not very important. Bending temperature, cold bending shall be done at a temperature below the transformation range, that is below 700. Hot bending shall be done at temperature above the transformation and in any case within a temperature range consistent. Then hot bending and forming, this is important. Except carbon steel, if you are going for hot bending, any other material, PWC is mandatory. This is important. After hot bending and forming, heat treatment is required for P number 3, 4, 5, 6, and 10 mm metal, all thickness. That is open to question. Now, distortion. So what is mean by distortion? Means piping is not aligned. It is not vertical or it is not horizontal. Any distortion, you should not bend the pipe to make it correct. It is not allowed. So highlight this one. Any distortion of the pipe to bring into alignment for joint assembly that introduce a detrimental strain is prohibited. That is open to question. The next point, flanged joints. Now, there are two requirements. See, when you make a flange, suppose flange is not matching, just offset is there. It is not exactly matching. How much offset is allowed is 3 mm. Okay, in any 200 mm, 200 mm, 1 mm. So 1 mm into any 200 mm. Bolt offset, suppose bolt hole is rotated, bolt hole is not matching, 3 mm offset is allowed. These two requirements are important. Flanged joints, before bolting, matting gasket surface shall be aligned with 1 mm in 200 mm. And 3 flange bolt shall be aligned within 3 mm maximum offset. Maximum 3 mm offset. That also, suppose bolt hole is shifted, not exactly matching. Then how much offset is allowed? 3 mm. Now, bolt should be completely come through the nut. Engaged. 570 we have different requirement. 570 even inside it is allowed, but construction it is not allowed. So highlight this one. This is close book question. Bolt shall extend through their nut such that there is complete thread engagement for the full depth of the nut. So code does not say how much thread to come outside. 1 thread, 2 thread. The code does not say. It should be completely come out. That's all. This is close book question recently asked. Then gasket, we have to use only single gasket. Multiple gasket should not be used. No more than one gasket shall be used between the contact faces in assembling the flanged. Then thread compound or lubricant. Suppose you are going to threaded joint and make welding, lubricant should not use. Any compound or rod used on threaded shall be suitable for the service temperature and shall not react unfavorably. Seal welding, a threaded joint seal weld shall be made without a thread comb. Just to highlight this, these are not important. So that is the end of chapter 4, 5, sorry, chapter 5. Then we'll go to the chapter 6. Inspection, examination, testing. There will be 5 questions, 4 to 5 questions will be asked from the inspection, examination, and testing. This is the last chapter, day-3.1. Now, I will briefly say what is inspection, examination, and testing. Then we will go through the code book. In code language, inspection means inspection carried out by the owner inspector. 25 இங்க ரொம்ப வாமா இருக்கு. அப்படியா? Okay. Right. Okay. Inspection means inspection conducted by the owner inspector. So what is the qualification required for the owner inspectors? Owner na client. Owner means client. He should have 10 years experience in the inspection of the piping. If you have any of the qualification like engineering degree or AWS CWA or AP 570, a 5-year can be reduced from the experience. So any one of this degree plus 5 years. That is the requirement. Now, what is the examination means? Examination means conducted by the contractor, NDE, non-tested examination. Now, the next one, what I am going to say is important. From there only exam question. There are 2 types of weld I told. One is girth weld, another one is the longitudinal weld. Longitudinal weld generally done by the pipe manufacturer. Girth weld is done at the site. You can make a longitudinal weld also at site. Suppose you are going to fabricate pipe itself on the site, it is allowed. Now, first one, I will complete girth weld, then I will go. Girth na circumferential weld. Category D, first these are the girth weld requirements. Category D, 100% visual, no radiograph. Girth weld, what is the NDT requirement for category D? 100% visual, no radiograph. Category M and normal fluid, 5% visual, 5% radiograph. Severe cyclic, 100% visual, 100% radiograph. Again, I will repeat. Girth weld requirement is category D, 100% visual, no radiograph. Normal fluid and category M, 5% visual. 5% means each welder, every 20 joints, 1 joint you have to take radiograph. That is the meaning of 5%. 5% visual, 5% radiography. And severe cyclic means 100% visual, 100% radiography. Suppose you are making a longitudinal weld at the site. Any service, 100% visual is mandatory. Radiography percentage depends on what EJ you want. EJ, you know, remember table A1B, EJ, what EJ you have to take radiography. Whether now, what are the different type of radiography we have? Full radiography, 100% radiography, random radiography, spot radiography, random spot radiography. 4 types of radiography. 100% radiography means the entire joint will take radiography. Random means for each welder, every 20 joints, we will select 1 joint and that joint will be fully radiographed. So 5% means, for example, if a welder is making 100 joints, 5 joints we will select and take full radiography. Spot radiography for longitudinal weld. Random radiography for circumferential weld. Spot means, what is the mean by spot? Every 100 feet longitudinal weld, 1 feet you have to take radiography. This is a closed book question. Spot radiography means every 100 feet longitudinal weld, 1 feet we have to take radiography. Now you will ask a question. Suppose the welder is making only 5 feet. Then minimum length should be 6 inch. Spot radiography minimum length 6 inch. Closed book question. What should be the radiography requirement? Now, every 100 feet, 1 feet. Closed book question. Random radiography, every 20 joints, 1 joint. Closed book question. What is the category D NDT requirements? 100% visual, no radiograph. Category of normal fluid, 5% visual, 5% radiograph. Severe cyclic, 100% visual, 100% radiograph. This all closed book questions. Then radiography acceptance criteria is given, which is a open book question, little bit tough. That one we will interpret it. It will be little bit tough. Okay. Now coming to the PT, MT, RT, UT, we have to follow ASME section 5. So UT acceptance criteria, they never ask in the exam. PTMT also, they never ask in the exam. But I will say, what is PTMT acceptance criteria? PTMT, when you are seeing the indication, how the PT indication will be red color. We have to measure the indication, that only considered for the acceptance criteria. We will not clean it and see the hole or crack. Okay. When you see the indication, first you have to classify whether it is a relevant or non-relevant. Relevant means any indication length greater than 1.5 millimeter is relevant. If it is less than 1.5, leave it, accept it, not relevant. Once it is more than 1.5 relevant, then you have to find out it is a circular or elliptical. So what is meant by rounded indication means we have to measure the length, we have to measure the width. Suppose width is 3 mm, length is 8 mm, it is considered as a rounded. 3 times, it is more than 3 times only, it is called as a linear indication. Now, what is the acceptance criteria? Relevant linear indication is not acceptable. That means linear means lengthwise dimension is more than relevant now 1.5 mm. So any indication, linear indication more than 1.5 mm not acceptable. Rounded indication more than 5 mm not acceptable. This acceptance criteria never asked in the exam. In the exam, get it. But RT acceptance criteria they will ask. Okay, this PT, MT, UT acceptance criteria not important. Okay. Another one, there is one thing called progressive sampling, that also they will not ask in the exam. What is meant by progressive sampling? 5% radiography. For welders, they are making 60 joints. How many joints? 5% we have to take 3 joints. If 3 joints are acceptable, 60 joints are accepted. 1 joint repair, there is a 2 penalty. Another, the 2 any repairs, again 2 penalty. Third slot also there is a repair. We have to take radiography of all the 60 joints, but it is also never asked in the exam. So exam point of view, what I said, the 5%, these are the important things. So please take, we will complete up to the radiography. So highlight this one. It is the owner responsibility exercised through the owner inspector to verify that all required examination and testing have been completed and inspect the piping to the extent necessary to be satisfied, confirm the applicable. Highlight that one. 3340.2. Then who is the water inspector? Highlight the first 3 line A 340. The water inspector shall be designated by the owner and shall be the owner. Owner can be also an inspector, or employee of the owner, or employee of the engineering or scientific organization, or employee of the recognized insurance and inspection company acting as the owner agent. The owner inspector shall not represent the employee of the manufacturer or fabricator. You cannot hire inspector from a contract. You cannot work as a owner inspector, a contract inspector. Then what is examination? Highlight this one, 341. Examination applied to quality control function performed by the manufacturers, fabricator, or erector. That is called. Now examination requirement, these are not important. Now coming to the 341.4, next page. Normal fluid service. Piping in normal fluid shall be examined to the extent specified herein or any greater extended visual examination. A. At least the following shall be examined. 2. At least 5% of the fabrication, that is a girth weld. So normal fluid, 5% visual, and 100% of completed welds are longitudinal welds, 100%. So it is not clear. Say they everywhere they just write near the 2 girth weld, 5% girth weld, 3 is 100% is longitudinal weld. 100% longitudinal weld, here 5% girth weld. Then please go to the next page. Just to skip this, we will come back. Please go to the page number 87. Other examination. Not less than 5% of the circumferential butt and mitral shall be examined by random radiography. That is important. Close book question. So it is continuation of the normal fluid. So 5% visual, 5% random radiography. Now these are not important. Then category D, 341.2. Piping and piping elements for category service as decision danger shall be visually examined according with the para 344.2. Highlight this one. And the severe cyclic also here, sorry. Severe cyclic, highlight the A here. Visual examination. All fabrication shall be examined. 100% exam visual. And other examination, all circumferential mitochondrial shall be 100% radiograph. Now, the code here, it is not clear. So please copy this one, what I write. Girthwald, category D, %% visual, no radiograph. Normal fluid, and category M, because both are coming under same condition only. 5% visual, 5% radiograph. Severe cyclic, %% visual, 100% radiograph. The next longitudinal weld, any service, %% visual, RT depends on EJ. This is the everywhere they refer some section. So if you go to the section, that is the meaning of this. EJ means joint deficiency. Okay. Then, okay, right. We'll go back to the code book. Then please come to the spot radiograph. Next page, page number 88. This is important close book question. Longitudinal weld. Spot radiography for longitude 341.5.1. Guru welds required to have the weld joint factor EJ 0.9 required examination by radiography at least 1 foot in 100 feet for each weld welder. So 1 foot in 100 feet. Every 100 feet, 1 feet you have to take radiograph. Then circumferential, it is recommended that the extent of examination not less than 1 shot for each 20 wells for each welder. That is 5%. Then these are not important. Then highlight this one, hardness test. Now hardness test they removed. Hardness tests are not required to verify proper heat treatment except otherwise specified in the engineering design. Then this is the MTPT. You can see here MT. So visual, we have to follow section 5. Everything you have to follow section 5. Just MT highlight it, but they never ask in the exam so far. So highlight it. An indication of an imperfection may be larger than the imperfection that causes it. However, the size of the indication is the basis for acceptance. Only indication have any dimension greater than 1.5 mm shall be considered relevant. If they ask, it will be open book only. No need to memorize anything. Then here, this is the linear indication is one having a length greater than 3 times width. Rounded indication is one circular or elliptical having a length equal or less than 3 times width. All surface to be examined shall be free of relevant linear indication. Relevant round indication greater than 5 mm. Suppose less than 5 mm, 3 indications are allowed. 4 or more indication in a separated by 1.5 mm. Just to highlight it. These are they ask only open book. Now we'll go to the next page. What are the different type of radiography? 100% radiography, random, spot. Now this is important. For longitudinal weld, the minimum requirement is 6 inch. We have to take radiograph. Minimum spot radiography means 6 inch. That is a closed book question. Ultrasonic, it is not important. So before completing testing, we will go to the radiography acceptance criteria. So please come to the page number 84. Maybe exam, there may be one open book question from this acceptance criteria. Now, this table is applicable for visual and radiography. For both, this table is applicable. You can see here, I highlighted some of this because this they will not ask in the exam. Crack they will not ask in the exam because crack is not any service not allowed. So crack they will not ask. Round indication they will not ask in the exam. Reason is round indication you have to refer section 8. Section 8 is not part of our exam. Surface porosity they will not ask them. Again, it is not acceptable. Surface finish they will not ask in the exam. Root concavity they will not ask because root concavity rule says we have to measure the density. Now, what is the left out? Lack of vision, incomplete penetration, linear indication, undercut, and reinforcement. These 5 are important for exam. Only 5 are important for exam. Now, how to interpret it? See, you can see here, normal and category M, it is in here, severe cycle here, and category D here. Each one we have the girth, mitral groove, longitudinal, and fillet weld like this. There is some symbol is given. Let us start. I will work it one. For example, we will take any fluid service. Which fluid you want to take? Category M. Okay, no problem. What is the thickness you want to check in inches? 6 mm. 6 mm means quarter inch, or you can use mm also, no problem. 6 mm. I told you the important is which type of weld? Girth weld. Okay, right. Girth weld. Lack of fusion they can ask. Lack of penetration they can ask. Undercut they can ask. Linear indication. Then reinforcement. So this 5 only important for exam. Now, what is the symbol is given? Just tell me the symbol. Category M, girth weld. So you can see here. Girth weld. See, it is the category M. This is the girth weld. Lack of vision A. Incomplete penetration B. Okay, just to tell me the symbol. Undercut H. Linear indication reinforcement L. So you have to interpret the symbol. The interpretation is given in the next page. You can go to the next page. A means 0. 0 means not allowed. Okay. So A means 0 mm. What is the maximum allowed is 0 mm. What is the B? What is the B explanation is given here? Cumulative length less than or equal to 38 mm in any 150 mm weld length. So for weld length, I didn't give you. So less than or equal to 38 mm allowed. So cumulative length less than or equal to 38 mm in 150 mm length. Now coming to undercut H. What is the H? Depth of the undercut 1 mm and TW by 4. Now, what is the meaning of and? You can see here there is a note here at the bottom. Highlight the note 1, where 2 limiting values are separated by and. Same page bottom. Lesser of the value determines acceptable. When there is a and, you have to take the lower value. When 2 sets of values are separated or the larger value is acceptable. We have to take the larger one. If come R, larger value, and comes smaller value. Now here H less than 1 mm and TW by 4. So So first there are two things, depth of undercut and cumulative length undercut. Sorry, H, cumulative length. Okay. So first we have to see depth. So depth, what is the rule? Lesser of 1 mm or TW by 4. So 6 mm is thickness divided by 4, what will come? 1.5 mm. 1.5 and 1, which is the lower value? 1 mm. So it should be less than or equal to 1 mm. So and means we have to, TW means thickness of the weld. That's why I asked you the thickness. Now cumulative length less than or equal to 38 mm. It is given next one. H. You can see here H. Cumulative length less than 38 mm. The next one is linear indication. What is the linear indication? G. So if you say G, there are three. So linear indication, individual length less than 2 times thickness. So length is given, cumulative length, individual length, width, and cumulative length. Okay. So we have to G. There are three things are there. Length is there, width is there, and cumulative length. So what is the length rule? 2 TW. So thickness is 6 mm. 2 into 6 is 12 mm. What is the width rule? 3 TW by 2 also 3 mm only. So less than 3 mm. Cumulative length? So 4 means 24 mm. Note 2, nothing will be there. No problem. Don't worry about the note. So 4 TW. Yeah. Then finally, L reinforcement less than or 6 mm reinforcement, then it should be 1.5 mm. Reinforcement height less than or equal to 1.5 mm. Now exam they will not ask like this. Okay, I will write an exam question. You write this and find out. So I will write question. This is the question. What is the maximum undercut depth and reinforcement allowed for category D girth weld of 3 mm thickness. Try this question. Please copy this and try this question. What is the maximum undercut depth? We are asking only undercut depth, not all undercut. So we are asking undercut depth and reinforcement, category D, thickness is 3 mm. And girth weld, it is a girth weld. So please copy this, then answer this question. Okay, what is the answer? Reinforcement. Okay, so let me interpret. So first we have to see the symbol. Okay. So category D girth weld. So we go to the category D girth weld. Okay. Undercut depth, undercut was the girth weld I and M. So we have to interpret I and M. If you go to the I asked only depth less than 1.5 mm and TW by 4 or 1 mm. See, first when there is a bracket, first you have to solve this one mathematically when there is a bracket. So what is the TW by 4? I told 3. 3 by 4 or 1 mm. R means higher value you have to take. So 1 mm we have to take. Then come outside 1.5 and 1. Whichever is the lower value you have to take. So answer is 1 mm. So the first one undercut answer is undercut depth answer is 1 mm. Reinforcement M. So M, what is it is given here? 1 M is the limit is twice the value L above. So for example, less than 6 mm, L is 1.5 mm. So 2 times of 1.5 mm, we have to take 3 mm. So reinforcement is equal to 3 mm. They are given symbol M. What is the meaning of the M? What is the L given? We have to take 2 times of the L. So L, it is 1.5 mm or 6 mm less than 6 mm. M, we have to take the double value. Okay. So this is about this interpretation may be one question, not a regular question, but if you are not understanding, it will be a little bit tough. Other things are. So now we will go to the, yeah, maximum.
This minimum is base metal.
There is no minimum is base metal. That's all. Then if it is go less than that, that is called underfill. Underfill is not allowed. Okay. So let us go to the next chapter, testing. Here, page number 90. Testing. 90 testing. Testing, there will be 2 questions. I told you total there will be 4 or 5 questions. Testing side, they will ask 2 questions. Important. First, what are the different type of tests we are doing? There are 3 types of tests in the piping. In-service test, hydro test, pneumatic test. Let us explain one by one. What is meant by in-service test? It is allowed for only category D fluid service. So in-service test is allowed for only category D. And that's also owner option. If the owner thinks, owner accept that, we can go for a in-service test. What is in-service test means? Hydro test, we will use water. Pneumatic test, we will use air. In-service means actual service fluid we will use it. Suppose it is a lube oil line, we will use a lube oil for testing also. Same nitrogen line, we will use for nitrogen also. Okay. So again, I will repeat, in-service test is allowed only for category D at the owner option. Then what is the test pressure? There is no formula. It is operating pressure. Only operating pressure. They will pressurize, hold for 10 minutes. If there is no leakage, the test is acceptable. That's all in service. Now coming to the hydro test. Hydro test is the preferred test. Pneumatic test is generally not preferred because of the safety hazard. Pneumatic test is dangerous. We are compressing the air, compressing the gas. So any leakage will blow up everything. It can injure people nearby. That's why when they are doing pneumatic test, they will barricade the area. They will not allow people to enter it. Hydro test, your water cannot be compressed. So even there is a leakage, it will be like a jet. It will not injure. So pneumatic test is generally not preferred. Only hydro test is preferred. Then why we are doing sometimes pneumatic tests? There may be some reasons for that. One of the reason is the foundation or supporting structure will not withstand the weight of the water. Then you have to go for pneumatic. Second one, maybe there is no draining possibility. Then we have to go for pneumatic test. Third, they have internal lining like a refractory, which will be damaged by water going inside. Then you have to go for pneumatic test. Fourth, maybe, okay, inside of that water, you drain it, there may be moisture, which can cause severe corrosion in the particular service. If any one of the reason exists, then they will go for a pneumatic test. Otherwise, only they will go for a hydro test. Now, what are the requirements you should know about the hydro test? First one, before testing, all NDT, PWST, all hot work should be completed. Because generally after hydro test, welding and PWC is not allowed. Again, then we have to do hydro test. Now, second important thing is for large piping, because we are not testing one by one pipe, we are testing the pipe circuit. We call it as a test pack in construction. When you are testing a large circuit, what the code recommends, go for a preliminary air test. First fill with the air to locate the major leaks. What should be the pressure? 25 psi. That is important. Preliminary air test pressure is 25 psi. That is a closed loop question. Then you can go for a hydro test. Now, when you are going for a hydro test, what is the formula we have to use for the hydro test? So 1.5 design pressure, stress at test temperature divided by stress at design temperature. Where you will find a stress? Appendix A1. Test temperature, generally they will not give in the exam up to 100 degree Fahrenheit, because that is the test temperature. The first column, that is for A106 grade B, 20 KSI we have to take. Design temperature they will give in the exam question. So we have to this one. Now, when you pressurize it, we have to reduce the pressure. So you have to hold for 10 minutes, then reduce the pressure to the design pressure, then go for inspection. That is the code rules. But generally during that also people will do the inspection. Now the next one is, suppose if you are, okay, that's all actually hydro test. Right. Next one is we'll go for a pneumatic test. Now, pneumatic test, what is the formula is 1.1 into design pressure. Point number one. There is no stress ratio. Second point is, when you are doing pneumatic test, you should not continuously pressurize. It should be 2 steps. The first step is 50% of the test pressure or 25 psi, whichever is less. For example, your pneumatic test pressure is 100 psi. What is the 50%? 50 or 25, which is less? 25. Your pressure is 25, then hold it. Then we can go for the 100 psi. Third important thing is, when your pneumatic test going for, you have to put a pressure relief valve, safety valve, so that sudden pressure increase will not result in a problem. So what should be the set pressure of this? Your pneumatic test pressure plus 50 psi or 10%, whichever is less. Okay, just 2-3 times read it will be so. And sometimes if you want to go for a pneumatic test, the maximum pressure allowed is 1.3 times of the test pressure. So these are the key points you should know in the testing. Okay, just give me 2 minutes, I'm coming, then we'll continue. Right. So testing, page number 90. At the owner's option, a piping system in category D fluid service may be subject to an initial service leak test in lieu of the hydrostatic test. That is important. Pose the question. So if the owner's option only, category D fluid may be subject to the initial service test. Okay, it is other fluids, it is not allowed. Page number 90, 345.1, paragraph A. The next page. When the owner considered both the hydrostatic and pneumatic impractical and alternative specified may be used, a hydrostatic test to damage linings, contaminate the process, require significant support modification, present danger of brittle fracture. Actually, these are not important. Then reduce the test pressure. See, this is important. What it says, see, but you are following the formula 1.5 times that formula. Suppose that pressure is greater than yield strength. I told you, when material crosses yield strength, what will have? There will be a permanent deformation. So you have to reduce the pressure. Okay, so highlight this one. If the test pressure would produce a circumferential or longitudinal stress, in excess of the yield strength at a tested temperature or is greater than 1.5 componenting, the test pressure may be reduced to the maximum pressure that will not exceed the lesser of yield strength. So less than yield strength, we have to use it. That is important open book question. Then preliminary pneumatic test. This is another important. A preliminary test using air at no more than 25 psi may be made prior to hydrostatic to locate the major leaks. That is closed book question. Then holding time, this is a closed book. The leak test pressure shall be maintained for at least 10 minutes, and then all joint and connection shall be examined for leak. The test pressure may be reduced to not less than the design pressure also. It can be design pressure, but it should not be less than design pressure. Heat treatment, leak test shall be conducted after any heat treatment has been completed. That also important. Now closure weld. Low test temperature highlight the possibility of brittle fracture shall be considered when conducting the leak test at metal temperature near the ductile to brittle. Suppose your atmospheric temperature is very low, you should be very careful during hydro test to avoid the brittle fracture. Now closure weld. See, generally when you are making a hydro test, you may make a blind of some area. The final connection testing is not possible. That is called closure weld. So what we will do, we will do the NDT. The joints are called as a golden joints. Okay. The final weld connecting piping system or component that have been successfully tested need not be leak tested, provided the welds examined in process accordance with the and para 344 and passes 100% radiography or ultrasound. That is closed book question. Then go to the next page. Records. Highlight this paragraph. The records need not be retained after completion of the test if a certification by the inspector that the piping has satisfactorily passed. Suppose entire test pack, you no need to retain, only the certificate, it is passed. That is necessary. Then temporary supports. This is important. Piping designed for vapor or gas shall be provided with additional temporary supports if necessary to support the weight of the liquid. Suppose you are doing hydro test of the gas line. So we may need additional supports. Then hydrostatic test. So highlight this. The fluid shall be water. We have to use water. Unless there is a possibility of damage due to freezing, the adverse effect water in the piping. In that case, another suitable non-toxic liquid may be used. If the liquid is flammable, the flash point should be at least 120 degrees Fahrenheit. Then test pressure. This formula is important. Open book. PT is equal to 1.5 P ST by S. So PT minimum test pressure, S is allowable stress at the design temperature, and ST is the allowable stress at the test temperature. So first test divided by design. That is open book question. The next page, pneumatic test. 345.5.1. Pneumatic testing involves the hazard of the release energy stored in the compressed gas. Particular care must therefore be taken to minimize the chance of brittle fracture during pneumatic test. Test temperature is important in this regard and must be considered. Then pressure relief device. This is closed book question. A pressure relief device shall be provided having a set pressure not higher than test pressure plus lesser of 50 psi or 10%. That is important. Test fluid. The gas used in the test fluid, not air, shall be non-flammable, non-toxic. Highlight this one. And test pressure, the test pressure shall be not less than 1.1 times the design pressure and shall not exceed 1.33 times. So next one no need, because it is 90% of the hydro test will be 1.33 only, less than 1.31. So don't worry B. So what is the pneumatic test pressure is 1.1 into design pressure. Maximum pressure allowed is pneumatic 1.33. Procedure. The pressure shall be gradually increased until the gauge pressure is lesser of 1/2 of the test pressure or 25 psi is attained. So either 25 or half of the test pressure, and which time preliminary check shall be made. After that, thereafter the pressure shall be gradually increased and in steps until the test pressure is holding the pressure at each step long enough to equalize. So how many steps code does not say. Then in service test. The test is applicable only for category D at the owner option. The test fluid is the service fluid. Then this is important. During prior to initial operation, the pressure shall be gradually increased in step until the operating pressure is reached. Then there is one thing called a sensitive leak test. If you highlight this one, the test pressure shall be at least lesser of 15 psi or 25%. It is not important. The next page, records. Unless otherwise specified by the engineering design, the following record shall be retained for 5 years. That is important. Examination procedure, qualification report should be retained for 5 years after the record is generated. Okay. Now, we will do some workout. So I will give you some data. So you have to work it out. Material. A106 grade B. Design temperature 600 degree Fahrenheit. Design pressure 150 psi. Operating pressure 120 psi. So now we have to calculate what are the things I am writing here. First, we will start with the hydro test. So A, test pressure, calculated. B, preliminary air test pressure. Next one is pneumatic. Same data only we are going to use. Test pressure, maximum test pressure, first stage. Test pressure, pressure relief device, PR, pressure relief valve, set pressure. Third one is in service. So what is the test pressure for in service? Please calculate this. The data is given there. So stress we have to from table appendix A1. Okay, test temperature is the room temperature. Room temperature means less than 100 degree Fahrenheit. Okay, these are the answers. So if you don't understand anything, please ask. Please ask your doubts if you have any doubts. Huh? Stress was, see, first is the stress at the tested temperature is the, we have to take, I told, up to 100 degree Fahrenheit. If you go to the this one, so you can see here, A10 is grade B. So first one is minimum temperature 20. So you have to take, yeah, 20,000. So 600 is the next page. You can see 600, it is the 17.9. So you can put 20,000 divided by 16.9, answer will be same only. So you'll get answer 251 psi. So this one is 251 psi. Then next one is first stage 25 psi. Then test pressure here 1.1, 1.165 psi, maximum 1.3, 199. See, first stage is, this is 50% of 165 or 25, whichever is less. So 25. Here we have to add 10% or 50, whichever is less. So 10% will be 181. This is the operating pressure 120. Just ஒரு இது இருக்கு, ஹோல்ல சென்டென்ஸ் இருக்கு, அவ்வளவுதான். புக்ல இருக்கு பாருங்க. See, it is there. Preliminary air test. You can see preliminary pneumatic pressure. Preliminary test pressure no more than 25 psi. 345.2.1. Page number 91. There is no calculation. Preliminary pressure will be 25 psi before hydro test. Hello? Hello? Huh? Yes, there will be a calculation, but they will not ask you all this. Maybe anyone they will ask. Hello? Hmm. 181. Yes, what is your doubt? Yes, please. You ask something.
There is no maximum for hydrogen.
No, hydro test it is 1.5 times only maximum. But if it is crossing the yield strength, we have to reduce the pressure. We cannot go more than this one. Pneumatic test, the standard pressure is 1.1 times, but it can be maximum up to 1.33 times. So there are two ways. Generally, they are asking exam question 1.1 times. The maximum, how much it can go pneumatic, 1.3 times. Hydro test maximum is 1.5 times only. Okay, so that's all actually B31.3, because after that appendix A, all appendix we have covered yesterday. Okay.